I keep forgetting. Okay, we're Wednesday, week 4. We're starting with a problem from the turn-in homework on shape-shifting of percent format. The trickiest problem of that group because it's the one we see the least. In real life, we just never really have a mixed number percent. So knowing that replacing the percent with 1 over 100 just doesn't stick in our brain because we never actually see that. But there were 4 different ways to use replacements for percent, and one of them is a times 1 over 100. It's also true that we were talking about how you get a mixed number into an improper fraction, and you multiply and then you add. So why does that work? We had a picture. Okay, that's where we left off. Sorry, I forgot to start recording. Okay, more questions.
And in cases like that, are we always reducing the fraction?
Yep, fraction answers, you always just have to reduce them. I'm not sure why that annoying rule is there, but that's what it is.
So is the simplest way to say that is you're taking the whole number, multiplying it by the denominator, and then adding the numerator?
Sure. And then when you're done, you're putting everything back over the denominator.
Right, that simplifies it a lot for me.
And we're multiplying because each of our whole number, each of this 4, turned into a pie that had 3 pieces. So that's 4 3s. And then there's the one more, that was the partially shaded pie. Okay, other questions? So where we are is we've talked about all sorts of things with fractions, multiplying, dividing, adding, subtracting. We talked about mixed number subtraction, that you could do what we just did and make all of the mixed numbers into improper fractions. Or you could also treat it like place value if you like that better. We talked about order and terms and when the PEMDAS is useful and when PEMDAS could lead you astray if you were taught it badly. And regardless of if you know PEMDAS well or not, then terms just helps you take a long expression and manage it, make it into smaller bite-sized pieces. Goes with chains we mentioned, but that's more just to implant a seed of something in your brain. It's helping you with some intuition on how we move rates together in ways we don't use plain numbers. But there's a better way to do that process of goes with chains that we'll learn pretty soon. So that was something to sort of just to let marinate in your brain, but don't fuss about it too much. In percentages, we had different kinds of problems. Some say that we want to find the certain percent of something, just like 5 copies of $25 tickets, we could say what's 40% of some number. So this was the first type of percent problem that we're using more than one number together. And we discovered that of usually means multiply. So we could just change the percent into a decimal with RIPLOP and do our multiplying. So actually I will bring up a random problem. So which is more? So we have 2 different problems here. One is 24% of 628, and the other is 18% of 664. For both of them, we take the percent and we say, how do we get out of percent? With this kind of problem, the 2 decimal point scoots was the easiest option. Okay, going back to this other slide, which is the easiest way to get rid of percents in that situation. So this turns into 0.24 of becomes multiply 628. On the other side, we have 0.18 of becomes multiply 664. So who knows what these actually are? Let's see, 0.24 times 628. So this is 150.72. I'm not bothering to round because all I'm doing is picking which is bigger. 0.18 times 664 gives me 119.52. So this one is bigger. Is that good review of the first type of percent problems that we did on Monday? Moving on, there was a switcheroo trick. I'm not going to spend time reviewing it, but look at that if you wanted. We could move the percent from one number to the other. That's legitimate because we're just multiplying things in different order. So you can show off to your friends that way, but we're not worrying too much about that. Tipping was a good example of this. What's 10% or 20% or 15% of something? So we did a bunch of tipping examples. Then we left with sort of a warning that we don't need the word of. A jacket normally costs $80. It's on sale for 60% off. How much is the reduction? We're saying what is 60% of 80, but there's no of in the sentence, but that's okay. We could still do 0.6 times 80. And another warning that all of these percent of problems, they tell us, oops, the percent, right? Here is the percent, here is the percent. We're starting with Riplop because we have a percent. You can write an English sentence that has of, and there's no percent. It's asking you for the percent, but that's not what we're doing here. So those were the 2 warnings. Then we talked about percent change. Now we're up to page 443 in the book, or 6.5 in the green book. And percent change is the opposite. Instead of giving us the percent, then it's asking for the percent. So we have a candy bar. It starts at 75 cents. Oops, why did I put it all or something? It goes down by 15 cents. By the way, this problem doesn't tell us the new price, but I could write that if I wanted. What is the new price, by the way?
60 cents.
60 cents. Just take the 15 away. Does that make sense? So this isn't needed, but if we did want it, we could get it. Anyway, we have the change, and it says, what's the percent of that change? We want to take the 15 out of 75 and make it into a percent. So we're doing the opposite thing. If the one direction we multiply, it shouldn't be surprising that the other direction we divide. So our percent change formula was change divided by original. take my change and divide it by what I had originally. And whatever that is, 0.2. Then I need to use riplop. This time I'm going into percent. Again, this is the opposite of what we just did. Before we were going left out of percent. So if we're doing an opposite process, we shouldn't be surprised that now we're going right into percent. And we get our answer. Okay, this isn't quite as far as we got, but I want to pause here because not everyone that's watching now was attending Monday. Questions about this page and this page, the two opposite direction processes, either having a percent and saying what's the percent of a big number, or saying we have a change, how much is that change if we rewrite it as a percent of the original? No questions. We're all good. Okay, well, it will get harder and then you'll have questions. So this time was nice. They gave us the change and they gave us the original, and that's what the formula needs. The next thing that could go wrong was this problem, which maybe you remember. They didn't give us the change. So it starts at 80 cents. It goes down to 60 cents. And I want something here, but there's nothing there. I need to find the change so I can plug it in the formula. So, same as before, we didn't need the 60 cents, but the subtraction isn't hard. Here we do need the change. It's still true, it's just subtraction. So we get 20 cents of change with the 80 minus 60. Now I'm ready to plug things in. Did I write change divided by original? I did. Okay, I will do it exactly the same. Okay, everyone happy with this slide and comparing it to the previous slide? Yes, I see a thumbs up. Okay. So be careful. There might not be a change in the problem as it's worded, and you have to just do a tiny bit of work and find the change. But you need the change to plug it in the formula. Okay, and that's about where we got to on Monday. Now, what happens if we have, let me make this a little more narrow for now. A different issue to make things complicated. So 68 and 69 look very similar. So let's see how they work. So in 68, we're putting $200 in an account. Now it's going up by 3%. And we're wondering what the new amount is. But all it asks us for is the interest. So the interest is going to say that the change is 3%, but it's also so many dollars. I'm not yet worrying about what's in the account at the end of the year. So which type of problem is this? Is this one where we're trying to find a percent change, or is this one where we're trying to find the percent of an amount?
Trying to find a percent of an amount.
Percent of an amount, yeah. So we're doing this process, the multiplication that starts with your block. So we're wondering 3% of 200. So 0.03 times 200. 3% of 100 is 3, so this is going to be $6. So this is our answer here. Before I ask for questions, I'm going to move on to the next slide. And I will come back to this. So if you're not quite done copying, that's fine. This is a very similar looking problem. We're still putting in 200. It's still going up with a 3% change. It is still true that we're going to say how much is that change as a dollar amount. But now the answer we want is the new total. It's asking how much is it worth at the end of the year.
Wouldn't it be 206?
It is 206. We have to do exactly the same work. You don't need to actually write this twice like I am, but that's okay. But we have to take this $6 of going up and put it on the 200, and we get the 206. So it's exactly the same math. It's just that how it is worded, are they asking only for how much the interest is? Or is it asking what is the total worth of the account at the end? So be aware of that. This all comes together with this graphic here. I'm looking at a percent problem. If it asks me how much is the change as a number, does it just want that number, or do I have to combine it with the original? So to remind us of what's happening, that was the 200 going up, and we knew it was a 3% change. Are they wanting the $6, or are they wanting the total, which is 206? So are they wanting, Are they wanting to combine it? Or are they wanting just change that percent change into a dollar change or a number of apples change or whatever we're counting? That was one thing. The other one was if it asks for a percent, does it show or hide the number? That was the one where we had either going from 75 down, was it 15 cents? Or the other problem, it was 80 going down to 60, and we had to find the 20. Oh, these were cents, weren't they? Cents, cents, cents. Okay, cents don't always look very cent-like, do they? Okay, let's go over this again. So sometimes they give you an amount of a change and they say, please write that as a percent. In that case, there's two things that happen. Maybe they're nice and they show you the number, or maybe they're not nice and they hide the number and you have to find what it is. Another situation is that there is a change. They give you the change as a percent to start with, and they say, what is that change as a number? Instead of just as a percent. And then sometimes that number is all they want. And other times we have to put it back with what we had originally. Ready for more example problems? Our math isn't hard. All we're doing is either multiplying or dividing and a little bit of a plop, but we have these 4 situations to keep track of. So it's hard to do if you're really sleepy and falling asleep first thing in the morning if you need your caffeine. But if you're sort of mentally going, then it's not too bad. Okay, let's do bunches of examples. Let's start with a random homework problem. A dieter goes from 170 pounds to 151 pounds. So we just learned 4 different things. Figure out which one this is. Are they asking for the change as a percent, or are they asking for the change as a number?
Well, it says, what is the percent?
It says what is the percent, so they're asking for the percent. Are they showing us how much the change was, or did they hide it from us?
They hit it.
They hid it, right? It's not hard to find it. 170 minus 151 is going to be 19 pounds, but it wasn't there to start with. So this was first we say, look, they're asking for the percent, and then they are hiding it. So kind of identify which category of problem we're doing. Once we know that, then we can say, okay, percent change is change divided by original. So the change is 19. The original, I like my little diagrams with the arrow because it helps me not make mistakes. The 170 is the original amount. It went from there to something else. So that's why I draw this little kind of arrowy picture. So the original is the 170, whatever that is. So about 0.11, which will be 11%.
So we would round this answer then?
Yeah. Remember our general rules for rounding. Consider first the situation. Does this person know how much weight they changed to the 10th of a percent? Probably not. They probably don't even know it to 1%. Right? Measuring yourself on a scale just isn't that accurate. Did you just drink a bunch of water and eat something? Are you wearing the same amount of clothes? And so on. And also, the general rule for rounding was beyond the context, look what the numbers you have. These had 0 decimal points, so our answer probably will have 0 decimal points. Maybe add 1. If you wanted to do 11.2%, you could, but that's probably exaggerating how much accuracy we have in the story. Ready for another one? Okay. Let's do this one. There's a sales tax of 5%. How much sales tax is put on an item that costs that much? So are they asking for the change as a percent, or are they asking for the change as a number?
The number?
A number. So we're on this side of our situation. And do they want just the change as a number, or are we putting it back with the 667 at the end?
Just the change as a number?
Just the number. They could have asked us, how much money does the person spend, including the sales tax? Then we'd have to add it back on. But that's not what they asked us. They only wanted the number. So again, get your brain organized before you start, and you won't miss any points for no reason on a test. Okay, now this is the, what is the percent of something else type process. The percent we're going to riplop, get out of percent. Of becomes multiply. And whatever that is. $33.35. Okay, are we done? Should I do more example problems? How are people feeling about the percent change issues?
Let's do one more.
Do one more? Okay. Um, Let's look at the turn-in homework. Okay, I don't want to do your turn-in homework for you. So let's change the numbers, and instead of 5%, say that's 7%. Should we change the price tag also? No? Okay. So the price tag before sales tax says 100. There's a 7% tax rate. What's the total price? So are we looking for a percent, or are we looking for a number?
We're looking for a number.
We're looking for a number, right? And do we want just what is the 7% of 100, or are we going to combine it back with the 100 when we're done?
We want the total.
Yeah. Because it says, what's the total price, including the tax? Everyone happy with my setup?
Yes.
Okay, so again, we have 7% of 100. Of becomes times. Then I have to take the 100, combine it with that 7, and I get my answer. Okay. So that's sort of your overview. Keep your brain organized. Now, if you are good at multiplying by 100, this last problem might have seemed really easy, right? 7 out of 100 times 100 is 7. That's not surprising. So let's use that kind of thing. And let's also say that this involves 2 steps, the step with the black pen writing and the step with the green pen writing. Is there a way to make this simpler so we don't need 2 different steps? And there is. So first I'm going to do this exact same problem just for the sake of having the lecture flow. I'm going to go a little speedy because this is so much the same as what we just did. There's a $100 loan. It's going up by 12%. And we want the total amount paid when we pay off the loan. We have to pay off the 100 and we have to pay off the interest. So this one is we want a number and we want to combine it with the 100 when we're done. So we're going to do 12% of 100. At the end of the time, you have to pay back not only the 100, but also the $12 interest. So again, 2 steps, the black writing to find the interest, the green writing to put it all together.
So the green writing is kind of off the page where you can't see.
You know, off the page where I can't see. I don't get to see my own shared screen. Is that better?
No, because I only see then plus, then a line, and then interest.
If you have everyone's like little cameras pulled up, you can minimize it so you don't have to see any of that and you can see what he's writing.
Up at the top, there's a kind of speaker view versus gallery view or something. Is that the
Yeah.
button you want?
Yeah.
Does that help? If it doesn't, let me know and I can do something else.
Or just make it full screen. I can see it as a full screen.
Did either full screen or speaker view help?
Yes, thank you.
Okay. I can also just grab this and like move it somewhere else, but I don't want to make extra slides. Okay. So let's try to not do 2 steps. So the 1+ trick says that if we're multiplying to do a % increase, we can add 1 to the % to keep the original amount around. So the same problem we just did, instead of doing 0.12 times 100, that was, in my picture, the 12% increase is this 12% here. That looks very sloppy. We're instead going to say, let's multiply it by 1. Oops. 0.12. And the 1.12 means that we're keeping around the 100, because anything times 1 stays the same. Let me be a little more consistent with my color coding. Might help people. So we have 1.12. The 1 comes from 1 times 100, so we keep the 100 around. That's like our green step down here of let's keep the 100 around. The 0.12 is the 12% we're changing. And we're putting them together, and when we do that, we just get the 112 as one step. We don't have to do a separate green step at the bottom to combine things at the end. So that's called our 1+ trick. And so let's do more of those. So I'm not going to do 0.08. Let me do my colors right. I'm not going to do 0.08 times 5,000. Oh, am I writing a 1? I have 5,000. I want to go up by 8%. And the 0.08 captures that change of 8%. But I'm also going to put a 1 in front because 5,000 times 1 keeps the 5,000 around also. And if I take 5,000 times 1.08, then I get 5,400 as one step without having to add on the 400 at the end. So you don't have to do this. There's nothing wrong with finding the change as a number and then adding it back onto the original as a second step. It's just a little bit faster to use the 1 plus trick. It's very easy to just put a 1 in front of a decimal, and then you get your answer in one step.
I like that. I think it makes it easier.
Most people like it. There's a lot of Math 20 that sort of, there's lots of ways to do this, you pick one. So some people just get kind of overwhelmed by too many choices, but that's part of why you take good notes and narrow down your notes so that you keep just the parts that work for you. Okay, let's do another one. Actually, I'm going to make it narrow so it fits on the screen a little better. Oh, okay. So we have something that's 140. It's going up, and we want to know what the new price is. The change is 12%. Can I leave off the riplops? Is it okay that I have no yellow riplop on this page? I think we are riplopped to death. If you want more riplop, let me know. So I'm not going to do a 0.12 times 140. There's nothing wrong with that. It's just a little slower. Instead, I'm going to do a 1.12. Then the 1 captures the 140. The 0.12 captures the 12%. And whatever that actually is. $156.80. So you're probably thinking, this is a nice trick, but it's very specific. So far, it's only for where they give you a number and they want the percent of the number and it's going up. What happens if they give you a number and a percent of a number and it's going down? Does it still work? And the answer is, sort of. So here we're starting at 200. We're going down by 15%. We're going to want some new amount. So let's think about how to do this. Don't start writing yet. I'm going to erase in a moment, so don't start writing it. If I have my 0.15, that's sort of what I would like to do, and I put a 1 in front of it, we know what's going to happen. That means go up by 15%. That's the wrong thing. So we don't want 0.15 more than 1. We want 0.15 less than 1. Okay, so what I'm going to need to do is take my 1 and subtract my 0.15. And actually, I'm going to write that in green. So it's still true that I have 1 capturing my original amount, so it doesn't go away. And I have a 0.15 saying that there's a 15% change, but now we're going down, so this has to be a minus sign there. So whatever that is, 170.
So then do you just use multiplication to go up?
What happened going up? So here we have a 1 minus the 0.15. Last slide, we had a very similar thing.
Okay.
This was a 1 plus a 0.12. And the plus meant going up. It's just that 1 plus 0.12 is so easy, we could just put the 1 in front. Does that make sense? Similarly, on this slide, we have a 1 plus a 0.08. The plus meant we're going up, but adding a 1 to a little decimal was so easy, we just put the 1 on front. So it looks less similar than it really is. We really were doing a plus here between the red and the blue. We just didn't have to write it because the math was so nice. With this kind of problem, you will eventually get so good at this that you don't need to write this part. If you like this and use it, then you can just get good at saying 1 minus 0.15 is 0.85, and you don't actually have to write all that. Just like adding 0.12 to 1, you don't actually have to write out 1 plus 0.12. But for most people, we're just not used to subtracting a little decimal from 1 quite as much as we are adding a little decimal to 1. So it's hard. Think about money. What's $1 minus 15 cents? It's 85 cents. So you don't have to do this. We could take the same problem, and again, the trick is just to save you time. We could say, what's 15% of the 200? Find out that the answer is $30. And then the 200 minus the 30 is the 170. There's nothing wrong with doing it 2 steps. It doesn't take really that much more writing. So there are plenty of Math 20 students that like the 1 plus trick, but they don't like the 1 minus trick. This is just a little bit less natural. And so for minus, they just do 2 steps, and that's fine. If you're in that camp, great. There's no problem doing math that way. If you like the tricks, there is a trick for going down. You just have to get your brain used to $1 minus 15 cents is 85 cents kind of thinking. Okay, questions about any of that? Okay, I want to point out something that was very different. So, here we go. With this slide, this wasn't a choice for you. This was that there's 4 different types of problems. Some go this way with this or this. Some go that way with this or this. You just have to be aware of all 4 things and be able to handle it. That's different than what we just did, where there's nothing wrong with adding on things at the end. But if you want, there's a shortcut. There's nothing wrong with subtracting things at the end. But if you want, there's a shortcut. Okay, so this is kind of 4 things, but you get to pick and choose. Whereas in the beginning of the lecture, it wasn't you getting to pick what to ignore. Okay, your questions before we move on to something different. No, okay. The last kind of thing, if you look at the turn-in problems, is simple interest. So we have time for that. We're now on either page 451 in the online green book or 6.7 in the zebra book. We've had a problem with interest already. Interest, if you think about it, is a fee that the lender charges the borrower. So if you have a savings account or a government bond, you are the lender. You are loaning your money to the bank or the government. So you get the fee, you collect the interest. If you have a bank account that you have a mortgage or a credit card that you owe money, then they are loaning money to you and you have to pay the interest. But interest is just a fee that the lender gets from the borrower. Another bit of jargon, the initial amount of the loan is called the principal. So simple interest has a design where everything happens in 1 year. And this is nothing new at all. We've been doing this all day. If we have a $500 loan and it goes up to a certain amount and the change is 2%, then all we're doing is increasing the 500 by 2%. We could use the 1 plus trick. We could multiply the 2% times the 500 and then add it back on. Anyone care which way we do it? Okay, I'll do the 1 plus trick then. So we have the 1.02, and again the 1 comes from the 500 sticking around. The 0.02 is the 2%. Multiply it by 500. And we get, what, 510? Mental math okay?
Yes.
So at this point, interest has nothing new. We've just been doing these. So there was a certain amount loaned, the principal. There was a fee, the interest, and it's designed that the fee goes with a 1-year time frame. At the end of 1 year, you pay back 510, not just 500.
Is that right?
So what if we,
Sorry, David, can we go back to that one
sure,
on 78?
Mhm.
And if you look in your mad science stuff there, click on
on that,
the answer there.
110. Ah, so it just needs fixing.
Okay,
It should
I was
be
gonna
fine.
say, 110 was an awful lot amount to have to pay.
Yeah, you have to pay back the whole loan. Okay, make a note to myself, fix 78.
All right, thank you.
No problem, thank you. By the way, you can tell by the style of the box, it's a different style than usual. So yeah, there's history of when this was put in and how awake it was and so on. Anyway, okay, so now we have this next way to make it slightly more complicated is if it's not 1 year. And are we at page 20? No, we have one more page. Okay. So in this case, it lasts 5 years. Actually, I need a different color because we're going to use that for the 1 plus trick. Other than that, it's the same problem. Instead of 1 year, now we have 5 years. So I'm still going to take my 500 and increase it by 2%. But this isn't the end. Because I'm going to keep increasing it after the first year. So I can't use the 1 plus trick. Instead, I have to go so for each year, we have the 0.02 times the 500 is $10. And then part B, no, actually I'm going to make 3 parts. Time out. 5 years. For every year, there's a $10 fee. So we're going to take the 10, multiply it by 5, and get 50. And then part C, don't forget the principal. If you showed up at the bank 5 years later and only gave them $50, they would say, hey, what about the $500 loan? So not too bad, but we're getting to lots of steps. None of this math was hard, but there's just lots of places to make a careless error. When there's more than 1 year, we can't use our friendly 1+ trick. We have to find the change as a dollar amount. 2% of 500 is 10. We have to say that happens 5 times because there's 5 years. And then we have to put the whole interest fee combined with the principal. And at the end of the 5 years, you pay that back to the bank.
I have a quick question.
Sure.
At the end of it, it says, what is the total amount paid at the end of this loan? But it doesn't say what is the total amount of interest paid at the end of this loan. So wouldn't it be like a 550?
It could say, instead of total amount, just what is the interest? And if they asked that, we would stop here because that's the interest. So I'm trying not to use the phrase total and interest. I'll save the word total for what we actually did in this problem, which is you combine the interest and the principal. Did that answer your question?
Yes, I was just thinking that we would be adding up also the 500 for 5 years.
No, because you don't get a new loan every January.
All right.
You're borrowing 500 because whatever, you need a new computer.
That's a cheap computer.
Yeah. And then every year, there's a $10 interest fee. And at the end of 5 years, you have to pay back the computer price and the $10 times 5.
That's what I got at first. I just think I let my brain overthink it.
Yeah, don't make these too hard. Most of Math 20, the big danger is making it too hard. Okay, we have a little bit more time. So how could this be slightly worse?
So on that last problem, could you have just done like $500 times 10%?
Your mic is cutting out. I couldn't quite hear what you asked.
For this problem, could you do 5 years, or sorry, $500 times 10% because it's a 5-year loan?
Yes, you could do the 2% times 5 first and then combine it with the 500. Okay, we're on our last slide. I need to actually grab our second Jamboard. This one didn't get cleared. Okay. Forget what I had copied. So this is a similar thing. Now the time frame oops, that's not a highlight, is 6 months. So half a year. So we have the same 3 parts. We're going to say, what is 2% of 500? Then we're going to say, how long does it happen? Now, instead of times 5, what am I going to do?
Well, we only need half of that $10 because that interest rate, the 10 is per year, and
Yeah.
we only need it for 6 months.
So I'll just divide it by 2. If this bothers you that I'm dividing by 2, I could also do times 6/12. That's the same, right? 6 months out of 12 months. So some people like this better. I'll write them both. These are the same thing, just 2 different ways to write it. And then part C, we have to take, not only do you have to pay back the 500 for your cheap computer, but you have to pay back the 5 also. And we get the 505. Oh, I did the wrong thing though. I don't actually need this since it just asked how much interest, going back to, who is it, Crystal's question. So I was actually done at this point. But if it did ask the total, then there we go, there's part C. Okay, so this was the important part. Everyone happy with if it's less than a year, you would shrink the interest. It's less than 1 year's fee. Okay, one last example. Let's move a little faster. No, let's not. Okay. So here we have a $2,000 loan. Our time frame is 200 days. It has a 20% simple interest rate. How much interest will be due? So step A is we say, well, if it was a year, that's what the 20% is sort of designed to do. Part B, what's our actual time frame? we don't have to pay all $400 of interest, thankfully. We stopped our loan early before the year happened. In this case, the division style isn't going to work very well. It's just hard to take 200 days and know what to divide. So I'm going to use the multiply by a fraction. Instead of 6 months out of 12 months, what fraction do I have?
$200 over $365.
Yeah. Everyone happy with that? Now in my calculator, remember that fraction bars are the same as division. So I can do 400 times 200 divided by 365. So what is that? 400 times 200 divided by 365 gives me $219.18. That's all this problem asked. How much interest will be due? It could have asked us for how much total do we pay back? If it did, then I just add them up. That's not what it did ask me, but it certainly could have if it just said something different at the end. And that's as hard as we can really get with percent change. What we've done is we've taken a simple percent change formula like we started with almost 2 hours ago, and we said, you know, this percent change assumes a 1-year time span. But for this type of loan, we don't have an entire year, so we have to do a fraction of days per year. Long ago, simple interest loans happened all the time. Before calculators and computers were around, if you wanted to borrow money from the bank for, whoops, we're on this Jamboard, several years, there were simple interest loans that did that. Nowadays, as you know from your credit card statements and bank statements, most long loans are compound interest, which we're not getting to in Math 20. That's a Math 25 topic. So about the only things that happen in real life where you would still see simple interest are payday loans. Someone knows that pretty soon they will get paid, but their water heater broke today, so I'm going to go to the payday loan store and get a loan for just a few days so I can fix my water heater and then I pay it back, or whatever your situation is. So this kind of thing happens in real life with payday loans. There's a designed for 1 year simple interest rate, and really this problem should say simple in it. I'll make a note also, 81 says simple. But no one borrows a payday loan for an entire year, so you shrink it to be 20 days or whatever your payday loan actually is. Let's look at the homework. So for the random problems, a small business borrows this amount. If it was a year, it would be 19%, but there's just a few days, exactly what we did. If we go back to what you turn in, then there's both a double it and a 2/12 and a number of days. So all three of the cases we did earlier. Number 7, by the way, is just easy, but has a lot of words. So people are going to ask me about number 7 when I see you on Monday. That is expected. Don't let the words confuse you, but if they do, that's okay. Don't let it ruin your weekend. It's not a hard problem. It's just, vomit words all over you. Right? Okay, the simple interest that people talk about all the time has this formula. And this formula is exactly what we've done. I can take the same problem and do the same math, but make it look like a formula. So I'm going to take the 200, that's or 1,000, take the 2,000, that's my principal. I'm going to multiply it by the 0.2, that's my annual interest rate. And then how much of a year is it? It was 200 out of 365. And whatever that answer was, 219.18. So once again, sometimes this helps you and sometimes people don't like this. The formula is convenient. It's reminding you that really all we're doing is multiplying 3 things. The 2,000 and the 0.02 and the fraction of how much of the year we're dealing with, or how many years we're dealing with. But the formula is also slightly dangerous because it doesn't remind you that my time frame is always in years. Make a fraction out of it. You have to remember how to use the formula. It's especially dangerous when people write it this way. Principal times rate times time. Because this one, you're really tempted when you see the t there to plug in 200 instead of 2/365. The more kind of conveniently catchy we make it, the less we forget what we're actually doing. So if you've done simple interest, and interest is principal times rate times time, rolls off the tip of your tongue nicely, then there's nothing wrong with the formula. But just remember that the time is something like a fraction if you're less than a year. So that's the warning there. Okay, pick one of these. We have time for one more, maybe 2. Do you want
We do the
84 with
first
a total? Or 85 with a total? What did you say, Spring?
Can we do the first one?
The first one? Sure. So I'll do this 2 ways. I'm going to first kind of do it the long way. and then I'll use the formula. You don't have to do both. I'm just doing both because I'm lecturing. Pick which works for you. So the long way says each year we had 4.5% of 3,500. Which is something. So $157.50. Then in 9 months, I'm going to take 9 months and change it to 9 months out of 12 months. And get $118.13. And then finally, we have to pay back. Oh, we don't have to pay back. Never mind, that's done. Woohoo. Okay. Everyone happy with that? If you were using the formula, we would say that the interest is that principal times the 0.045 times the 9/12. Let me see if I can squeeze in the words. Do it all in one thing and get the same answer. So remember that the R, the rate, needs your ripple up. And the T needs to be in years. Questions about 82? Okay, so that's the end of percentages in mad science. That's as hard as we can get for taking percents and squishing them together with other numbers. We will talk in Math 25 about compound interest. If I see any of you eventually in Math 25, we'll do that. But for now, this is where we stop.
Thank you.
You're welcome. Have a good weekend. Oh, one more quickie announcement thing. Not all of these problems have answers with them. Maybe these parts do. I guess I fixed these. If you get to problems in mad science that don't have answers with the lecture notes and you need them because it's annoying, let me know and I will do that. But otherwise, I'll spend my time making those highlight videos because I think those will help.
Is the